Hey Panthers, good morning. I'm sorry that I'm not with you today. I'm taking care of some family business today, but the learning will commence and continue, Panthers. By now you should have your ISN. You know that today we're going to add page 144 to the ISN. The heading should say Factoring with the GCF. And if you need a minute to get that done, go ahead. We'll pause the video for about a minute, and we'll give you time to get that set up. All right, Panthers. Today we're going to talk about factoring with the greatest common factor. Yesterday you found the greatest common factor in class. Today we want to factor with it. To factor an expression means to write it as a product. So we actually, and I'm going to scoot this over where you can see it, we actually factored yesterday when we made factor trees, when we were finding the greatest common factor. We wrote each of these numbers, we factored each number, because we wrote each number as a product. We wrote 24 as 2 times 3 times 2 times 2, for example. Today, and then later on I should point out that you factored polynomials. Here 15ab is factored as 5 times 3 times a times b. 21b cubed is 2 times 3 times b times b times b. Today, we're going to factor whole polynomials. A polynomial is the expression that has several terms in it, separated by plus or minus signs. So there are some examples, some basic examples here on the front of this foldable that show you examples of factoring. To factor this polynomial expression 2x plus 4y, I can find the greatest common factor, which is 2, and then rewrite the expression as 2 times whatever you would multiply by 2 to get 2x plus 4y. In this case, it's x plus 2y. Here's another example. Look at D. We would write 2m plus 6mn. Well, the greatest common factor is 2m. 2 divides into each term, and so does m to the first power. So I could write this same expression as 2m times 1 plus 3n. How can you check? I left room that you could do one of these, so let's just check D. Let's check D. If you write a factored version of the expression on D, one way to check would be to multiply it back out. And we modeled multiplication earlier last week with the box method. Here's one term times 2 terms. You could just use the distributive property if that's what you want to do. But if I want to check and see that 2m times 1 plus 3n gives this original expression, all I need to do is multiply. 2m times 1 is 2m, and 2m times positive 3n would be 6mn, and it's positive. And the expression I get, since I can't combine those like terms, is 2m plus 6mn, which is what we started with originally. So you should be able to factor a polynomial, and the way to check it would be by multiplying the factors back together and seeing if you don't get what you started with. This factoring idea is actually a really important idea in algebra. We're going to spend a lot of time working on different types of factoring because it's one of the things from Algebra 1 that you'll use quite a bit, especially when you study Algebra 2, and even a little bit next year in geometry. All right, Panthers, take a minute. We're going to then turn the page. We're going to look on the inside, and I'm going to show you some examples of how the factoring works. I'm also going to move the book out of the way. So Panthers, we'll take turns. I'll do one, and then I'll ask you to try one on your own. This first example, the instructions for each example will say factor each polynomial. I want to factor 8x to the 5th minus 12x cubed plus 4x to the 6th. The first thing I need to do is I need to find the greatest common factor. If you struggle with doing this without writing out the work, you should go back and write out the work. And I'll do a little bit of modeling of that. One thing that would be wise to check would be that the smallest coefficient, in this case the 4, does it divide evenly into the other terms? 4 divides into 8. 4 also divides into 12. In that case, 4 must be the greatest part of the greatest common factor. So what I need to do first is I need to do yesterday's problem. I need to find the greatest common factor. The coefficient part will be 4. Okay. And then what we said yesterday about the variables with powers is that if that variable is in every term, then choose the smallest power of that variable. Since x is in every term, x cubed would be the smallest. So how about x cubed? Okay. Now from here, there are a couple of different ways to think about the problem. What I know my answer is going to look like is this. It's going to look like 4x cubed times something minus something plus something. I know that what goes here is going to be the leftover part of each term, the part that I didn't use when I found the greatest common factor. I strongly recommend you think about making this into a backwards multiplication problem. So I have to multiply 4x cubed by something, and the something goes here. Something minus something plus something, to get 8x to the 5th minus 12x cubed plus 4x to the 6th is my answer. And I think I can decide what belongs here if I think about what I would multiply by 4x cubed to get 8x to the 5th. And right now I hope you're maybe thinking about division, and that's a really good way to think about it. I can solve this problem by dividing. What would I multiply by 4 to get 8? 2. And what would I multiply by x cubed to get x to the 5th? It would be x squared. And I'll do a quick little check. Does 4 times 2, 8? And is x to the 3rd times x squared x to the 5th? Yes. I've got it. So that's what's going to go here. That's my first term. 2x squared. What would I multiply by 4x cubed to get 12x cubed? Well, 4 times negative 12 would be negative 3. And I don't need to multiply anything by x cubed to get x cubed. I already have it. So I don't need to put anything here. 3 times 4 is 12x cubed. I've got negative 3. And then what do I need to multiply by 4x cubed to get 4x to the 6th? Well, I don't need a coefficient because I already have my 4, but I need to multiply x cubed by, I think it's x cubed, to get x to the 6th. And I can check that one as well. 4x cubed times x cubed is 4x to the 6th. So I need to put I need to put x cubed here. If you can make this a backwards multiplication problem, you should have no trouble, or very little trouble, I hope, finding what goes here. Panthers, we're going to pause the video now, and I want you to take about 2.5 minutes, and I want you to try to factor this. Find the greatest common factor, and then write it in factored form. Okay, Panthers. Let's try and find the greatest common factor. Let's see. I always start with the smallest number in the term. I'm going to pick 2. The only numbers that go into 2 are 1 and 2. Does 2 go evenly into 5 and 8? It goes into 8, but it doesn't go into 5. So it's not this. 1 goes evenly into 2, 5, and 8. So that's part of my greatest common factor, 1. And now I'll do the variables. An a is in every term, so what's the smallest power of a that I see? It's not a squared, because this a means a to the first. It's actually a to the first. And if b is in every term, what's the smallest power of b that I see? Yeah, it's b squared, right there. Good. So my greatest common factor is 1 a to the first, which I could just write as a, b squared. And if I now set up my backwards multiplication problem, I'll do it over here this time. AB squared should be my greatest common factor. And I need to figure out what to multiply it by to get 2a squared, b to the fourth, minus 5a cubed, b squared, plus 8ab cubed. So here we go. What can I multiply by a times b squared to get 2a squared, b to the fourth? Well, I need my 2. I've got one of the a's, so I need another a. I've got b squared. I need b to the fourth, so I'll put a b squared here. And I'll do a quick check. Is 2ab squared times ab squared 2a to the second, b to the fourth? Yes. So let's do the next term. I need my negative 5. I've got a. I need a to the third, so how about a squared? And I already have my b squared, so I don't need any b's. I just need minus 5a squared. Now let's do the last term. I need my plus 8. This time I already have my a, but I need one more b to make b cubed, so 8b. And a quick check. 8b times ab squared would be 8a b cubed. We've got it. So if you can make this a backwards multiplication problem, then I'm going to write my factored form as this times this. So let's write it. ab squared times 2ab squared minus 5a squared plus 8b. We've got her. Good job, Panthers. Let's look at 3. There's something different about 3, and I wanted to model that with you before you try it on your own. 3, we're trying to factor negative 5n to the fourth plus 15n cubed minus 40n. To find the greatest common factor, I'd like to take the smallest number that I see among the coefficients in 5 and think about what goes into 5. There's 1 and there's 5. That's the only pair. So I'm going to check, does 5 divide evenly into all 3 coefficients? And it does. So 5 is the greatest part of the greatest common factor. Now I also need to check my n's. Is n in every term? Yes. And this is n to the first, and that's the smallest power of n that I see. My greatest common factor is 5n to the first, or just 5n. Now, here's something else that I want to point out. When the first term is negative, we generally like to take the negative sign as well. Okay? So, it wouldn't necessarily be wrong if you didn't. You could get it correct, but there are a lot of advantages if the first term is negative for pulling the negative sign out. So let's do it. I need to factor. I need a 3-term box because there were 3 terms. I'm going to multiply something by negative 5n to get negative 5n to the fourth plus 15n cubed minus 40n. Well, here I've already got the negative 5 and I've got 1n. I need n cubed. This one can be tricky. What can I multiply by negative 5n to get positive 15n cubed? I need a negative 3. You see why it has to be negative? Negative 3 times negative 5 makes positive 15. And I think I need n squared. And here I've got negative 5n. I want negative 40n. I need negative 8. And now I can write my factored form. I've got negative 5n times n cubed minus 3n squared minus 8. Okay, Panthers, this video is going to end here. The next one's going to start with number 4 that we want you to try on your own.